Okay, let's talk about resistance here. All right, so resistance, here's the way the diagram looks. Notice we're doing conventional current. It's coming out of the battery here, right? Battery changes chemical energy, turns it into electrical energy. Coming out of the positive side, the current is because it's conventional current, right? And it comes through here, and it goes, comes through the light bulb. And that heat that it generates, that energy, that heat and energy that's generated there turns on the light. And that's the resistance. And in an ideal, in a voltic, not a voltic, in an ohmic system, which none really exists, but to get started, you always have to take the ideal situation and then go from there. And then start doing experiments and figuring out what's causing it to be from ideal. And that's doing science. All right. But to start to learn the concepts, you have to take an ideal situation. All right. So here we go. So we take the is the ratio of V divided by I. Okay, and that's Ohm's law. Okay, so V over I is equal to R, which is a constant. In other words, I want you to always remember this. For the most part, now I'm not going to say. I was getting ready to say resistance doesn't change. When you're working a problem like that, where V equals IR, so we've got Ohm's law, which says that V is equal to IR. Okay, where R is the resistance, I is the current, and V is the voltage of the system. Okay. For the most part, resistance doesn't change, but resistance does change. If something gets very, very hot, the resistance goes up. Change in temperature goes up, resistance changes. Okay? Temperature goes up, the resistance changes, and we'll look at that in a minute. But let's say I've got a 12-volt battery. Got a 12-volt battery, V equals 12 volts. And the amount of the resistance that I'm going to be pumping through to get this little motor to work is 200 ohms. Right? R is equal to 200 ohms. Then what's the current? You'll be like, really? That's all the harder this is? So resistance is given in volts per amp. Really? Jiminy Christmas. That's got to be my daughter. She sends one message at a time. Anyway, so, or one sentence at a time in her text. Anyway, so I'll say, well, V equals I times R. So to find the current, well, it's just 12 over 200. Which is equal to, you don't need to see the text. Excited young mommy in baby swimsuits. All right, anyway. Gosh, dang it. Son of a gun. All right, sorry about that. I thought I could turn that off, but I can't. All right, so anyway, now you're all up in my personal business here. Luckily, I didn't say anything about the students in that thing. So I've got 4 times 3 over 4 times 50, which is equal to 3 over 50. Which is equal to 0.06 amps. Not much amps. So to the extent that a wire or an electrical device offers to electric flow, it is called a resistor. Okay. Well, here we go. The filament in a light bulb is a resistor in the form of a thin piece of wire. The wire becomes hot enough to emit light because of the current in it. The flashlight uses 1.5 volt batteries, okay, to provide the current. So it's got 2 batteries in there in series. We'll learn about that after the next test. And so we stack them together, so we get 3 volts, 0.4 amps in the filament going through there. 7.5 ohms of resistance. 3 divided by 4, 7.5 ohms. Now, for a wide range of materials, like oven filaments and things like that, for a wide range of materials, the resistance of a piece of material over length across sectional area, this is what the resistance is. And you've got this resistivity in units. And let's look at this chart here. Notice really dinky resistivity in things that are conductors. I think that's supposed to be to the -4, not to the B power. I don't know what that is. But anyway, semiconductors, which are between insulators and conductors, which help us move electrons in one direction so that we can do computing things. Not so much. You know, a little bit less, 10 to the -5. These might be 10 to the -4 or something. Okay? Insulators. Huge resistance. Wood. You're not, the only way you're going to get any current to go through that is to hit it with lightning or plasma. That much energy. All right? So we'll talk about resistance and resistivity in the next slide.